Hello, good morning, friends. And today we are going to solve some NEET related questions which is asked in the year of 2022. See, on the topic of semiconductor devices. So, the first question is we need to find out a truth table for a given logic circuit. So, here they have given the circuit and they have given the options. So, which table is the correct one? So to find out, we have two different methods. So one, we can go for a lengthier one. So accordingly, the first I will take, I will take uh, 0 and 0 on both the cases. Means 0 is applying to input A and 0 is applying to input B. So this 0 is directly transferred here, and from A there is a NOT gate. So 0 becomes 1 here, and from B it is moving 0. Directly B is transferring, and here this B is also transferred to this gate. So we have gate number 1 and 2. The inputs are interconnected. So and the zeros flows into the NAND gate. So this gate is a symbol of NAND gate. So before that, what we can do is, so we'll draw the truth table of AND gate. So we all know for a AND gate, when input 0 0 is there, the output will be 0. Zeros and 1 also 0. 1 and 0 will be 0. Only when both the inputs are 1 1, then we will get the output 1. So in the NAND gate, my output will be, so the opposite of A into B. So this is 1 1 1 and 0. So this is a NAND gate. So 0 0 is there. So 0 0, the output will be 1. And here 1 comma 0 is there. So for 1 comma 0, the output will be 1. So when we supply 1 to 1 to AND gate, so this is a AND gate. This is also NAND gate. So there are two NAND gates and one is AND gate. So 1 comma 1 is supplied, then output will be 1. So among these four options, for a 0 0, we are getting output 1. So C is the output here. So see here, for a 0 0, output is 1. So this option is also wrong, and this option is also wrong, and here 0 0 is 1 is there. So between these two, I can get a correct option. So here next option what I will take is 1 comma 1. See, this is because the output are different here. So let me check 1 comma 1. So here the same circuit I am drawing here. So otherwise what I will do is I will erase all these things. Now I will supply 1 comma 1 here. So when A is supplied through the gate A, sorry, 1 is supplied to the gate A, so then A will come, 1 will come here. So this A again passes through this NOT gate, so 1 will become a 0 here, and from B, So 1 is directly supplying to this NAND gate, and this one flows to this NAND gate. So the first NAND gate has inputs 1 and 1. So if there is a 1 and 1 is there, then output will be 0 in the NAND gate. And if there is 0 and 1, so there is 0 and 1, then the output will be 1. So when 0 and 1 is there for a AND gate, so 0 comma 1 is there for a NAND gate, 0 comma 1 is there for an AND gate, so the output will be 0. So among these two, see, this option is wrong, so what we will get is here 1 comma 1, we are getting a 0 output. So this option D is the correct answer. So this is method number 1, and method number 2. So method number 2 is very simple. See, here again what I will do is I will erase the things. So when I supply the input A, now this will become A, and this A is passing through the NOT gate, and then it is giving input to the second gate. So here it will becomes a bar, and this is B, and here is also B. So when A and B are passing through the NAND gate, then this will become A into B bar. This is because A and B inputs are passing through the NAND gate. So A and B is representing a AND gate, and bar is representing a NAND gate. So here in the second NAND gate, what is happening? A bar and B is passing through the NAND gate. So this is A bar is passing through the NAND gate, becomes NAND is into B, and this is NAND gate. So what I will do is whole bar. So A bar is already there, so I have written A bar. So A bar and B is passing to the NAND gate. So A bar into B is passing through the NAND gate. Because of the NAND gate, I have put a bar over there. So now this A and B, this A and B bar and A bar into B bar becomes input to AND gate. So this is a AND gate. Now what it will come output, I can write C is equal to A into B bar into A bar into B whole bar. So this I can simplify. See, this A bar and whole raised to bar will become, see, this is A bar as it is, and this is B bar. So this will become a because bar get cancelled, and this will become B bar. So there is a B bar over here. Here is also there is a B bar is there, and here is also B bar is there. So the output what I will get is B bar into A bar into A. So we know A bar into A is a 1. So the option is B bar. So the final answer is B bar. So whatever the options B is there, so all the options will come opposite of that. So when there is a 0, there is a 1 option, there is a 1 is there, 0 is coming, C 0 is there, 1 is there, 0. This is just a opposite of B. The output what we are getting is opposite of B. So we can solve like this method number 2, or we can solve by this method number 1. Then the next problem is here in the circuit A, B and C, the potential drop across the two PN junction are equal in. So they have given a 3 circuit. So the one is both are P and N. Here is PN and NP is there in the circuit P, and here in the circuit C, NP as well as the NP is there. So to find out the potential drop, so they have asked us in which case the potential drop is equal, whether in circuit A or a B or a C. So to check the potential drop, uh, first we will understand in which case forward biases are there and which case reverse biases are there. So in the circuit A, I can take, see in the circuit A, P and N is there, and this again there is a P and N. So here what is happening, the positive terminal is connecting to P side and the negative terminal is connecting to N side. So this is representing in the both cases forward bias. So in both cases forward bias, and in the forward bias there is a depletion region is formed, and this depletion region is very narrow. So this depletion region we are calling it as the potential barrier. So this is, we are calling it as a potential barrier. So this is also we are calling it as a resistance, because which opposes the flow of current. So the potential barrier form in this first PN junction and in second PN junction will be the same. So the resistance here, this I can take a R1 and this I can take a R2. So the resistance here are same, and the current flowing, so these two resistors are in a series form. So the current flowing through this first PN junction and the current flowing through second PN junction, so in both cases I1 is equal to I2. So from this what we can conclude is that a potential drop is equal in the circuit 1. So PD of 1 will be equal to PD of second circuit. So this circuit is having the same potential drop. So A is the option. So let me check a second circuit. Second circuit, what it will indicate. So second circuit is like this. P and N, the series connections. There is N and P. So positive terminal of the battery is connected to P and negative terminal of the battery is connected to P here. So this becomes forward bias and this becomes a reverse bias. So in the forward bias, a depletion region is very small, means the resistance value is lesser. In the reverse bias, the depletion region is very large, so the resistance R2 is more. So R1 is not equal to R2 here. So the potential drop is not, potential drop across this first PN junction is not equal to potential drop across the second PN junction. So this circuit B option is a a wrong one. So only what we can get is a circuit A. So this is present in option number 2. And let me check about this circuit number C, because in the first option they have given circuit A as well as a circuit C. So circuit C is, the first is N and P. So they are interconnected. There is a again N and P. So there is a potential drop. So these two PN junctions are also connected in a series form, and the positive is supplying to N type, and negative is supplying to P type. So this is representing a reverse bias, and this is also representing a reverse bias. So in the reverse bias condition, here the depletion region R1 will be high, and here the depletion region R2 will be high. So in both the cases, the resistance value will be equal, R1 equal to R2. Both are reverse bias, so the depletion region is equal here, and both are connected in a series manner. So because of that, what is happening, a current flowing through both the PN junction are same. So what we can conclude, that the potential drop across the first PN junction will be equal to potential drop across second. So circuit C is also correct option. So in option A, they have given both the circuit A and C. So the option 1 is the correct answer. I hope you have all understood. Thank you.